In this video, we're going to look at solving trig equations. So our inverse trig functions are just like the inverses of regular functions when we did inverse of regular functions. So if we take the sine of x and we plug that into the sine inverse of x, we're going to get out the value of x. It's the same idea. The main difference with inverse trig functions is they don't pass the horizontal line test, so we have to restrict the domain to make it one-to-one. Okay, so inverse functions are limited to one period. So when we're dealing with inverse, we only calculate the principal angle, right? The angle that lies within the range of the inverse. So let's see what that looks like on a graph. So this is our sine function. This is sine of x here. They have restricted it to one or to half a cycle. Because if this were to continue, it would not pass the horizontal line test. So because we've restricted the domain, it can now pass the vertical line test. So this becomes the inverse function. So that's what I mean by the inverse function is only going to give you values that fall within its domain. Even if your angle is all the way out here, you're only going to get the angle that is in pi over 2 to pi over negative 2 for this particular function. Okay, cosine is the same way. Cosine has to be restricted between 0 and pi usually. And then that's what its inverse looks like. It's very important that you understand this relationship so that when we go to solving, hopefully it'll make a little bit more sense. And tangent inverse is even weirder. I had to do it backwards on the page, sorry. So this right here is tan of x, remember, because it has asymptotes at pi over 2. So it does pass the horizontal line test as long as we keep it in between a set of asymptotes. And then we can take the tan inverse like we did on this side. So let's try this. So we have that theta is equal to cosine inverse of 3/5. We could just put that into our calculator and get the value of theta. Except this particular problem wants an exact value. So we have to think back to SOHCAHTOA. So to undo an inverse, well, you multiply it by its function. So cosine of theta is equal to 3 over 5. We know cosine is a over h. So if we think of a triangle, A, H, and O, so in our case, A is 3, H is 5. So for sine squared theta, sine of theta is equal to O over H. Actually, it's sine squared, so it's that squared. So we have to figure out what O is. Again, we can go back to good old Pythagoras. So we can say 25 is equal to 3 squared plus O squared. So 25 minus 9 equals O squared. So O squared is equal to 16. So O is equal to plus or minus 4. Given that we're talking about positive things, I'm going to say O sticks with the positive 4. It is a 3, 4, 5 triangle. So that tells us that 4 over 5 squared is sine squared theta. So 16 over 25. So that's A. Now let's look at B. B is tangent, so it's opposite over adjacent. So tan squared theta is 4 over 3 squared. So 16 over 9. There you go. Now we're looking at solutions. Okay. So solutions to trig equations get tricky. So this particular function that is here is sine of x. And it's from negative 360 to positive 360. Just negative 2 pi to positive 2 pi. So if we look down here at the bottom, we see real fuzzy 2 pi, and then we can look over here, and again we see 2 pi. So this function is drawn sine of x for this domain. So we're good there. What this problem is asking is, where is the sine of x equal to 0.5? So we're going to take 0.5 and we're going to drag it all the way across our graph. And then we're going to identify how many solutions are we looking for. We're looking for 1, 2, 3, 4 different solutions. But if you solve for x and so if we did the sine inverse of 0.5 to get x, we are going to get 0.523. Which is pi over 6. So that is pi over 6. That's what our calculator gives us. That's not the rest of them. So there's a couple different ways you can think about it. I'll illustrate the first way in purple, and we'll do the other one a different color. So we look at where our function crosses the midline or crosses 0. In this case, it's right here at this dot. So we look at the distance here and say, okay, that's pi over 6. So we look at the next time we cross our midline, which is here, and then we go back pi over 6. So in our case, this is 5 pi over 6 is this point right here, okay? Because just like quadratics are symmetrical about their vertex, trig functions are symmetrical about the curve as well. It's going blue. The other way to think about it is, okay, what is the peak of your particular trig function? Okay, in our case, it's pi over 2. And what is the distance from your peak to the value that you solved? So that is going to be 3 pi over 6. So it's going to be 2 pi over 6, or pi over 3 is the distance there. So then you're going to take that and you're going to add that to the other side. So that's where we get the 5 pi over 6, and we can redo that on the other side. So this one here is negative 3 pi over, should be 2. And then we're going to go up. We're going to go positive pi over 3 and back pi over 3. So this particular solution going up is, so this becomes negative 9 pi over 6, 2 pi over 6. So this becomes 7 pi over 6. And this is negative 11 pi over 6. So those are the 4 solutions to this particular trig function. And we can look at this on graphing software like Desmos to prove that we're right. I don't mind if you use Desmos to help you understand problems, but you need to make sure you can do the math. Don't just use Desmos, trace, find the answers, and move on. Make sure you know how to do the math. Okay. So as we just saw, trig solutions can have more than one, and they're found through the symmetry of the curve. So if you need some steps to follow, these are the steps you can follow written out, so you don't have to keep rewinding to listen to what I just babbled on about. So here's a couple problems we're going to work. So to solve A, the first thing I want to do is I'm going to sketch for myself what cosine of 2x looks like. Okay, but I'm only going 0 to 180. So all I care about is this, and this is pi over 2, pi over 4, and this is 0. So, and I am looking for where it is 0.6. Well, this is going to be 1. Actually, this is going to be 2. 0.6 is greater than 1, so it's somewhere in here. So I know I'm going to be looking for 2 solutions. So I'm going to do 2x is equal to cosine inverse of 0.6. Be very cognizant as you're doing this what mode your calculator is in. So I'm going to get x is equal to 0.4636. That's in radians. Now I'm going to go ahead and switch the mode on my calculator and run these again. So I'm going to get 26.56 degrees. The reason I did that is because it gives us our domain restriction in degrees, so there's a good chance that they're going to want everything else in degrees. So that is one solution. That's 1 point towards solving the problem. So x is equal to 26.56. And now we have to figure out the next one. Well, we know from 0 to here is 26.56. Well, where are we 0 again? Well, we're 0 again at pi over 2, or 180 degrees. So our second x is going to be equal to 180 minus 26.56. Or 153.43. So those are our 2 solutions for the first function. And that's how you solve all of these problems. Draw yourself a little sketch, figure out how many solutions you're looking for, and then just calculate. I'll leave the other 3 because I have a feeling I'm going to need to work these through in class to help you out. But I encourage you to try one of these three, E, C, or G, in your notes right now, if not all three of them, and then come to class and we'll talk about them. So in this video, we looked at inverse trig functions and we looked at solving trigonometric equations. Here is your homework. It's 8, 10, 13, and 16. Don't forget to keep working on that. If you are struggling, find the page in the textbook, give it a read, and then maybe even practice some of these problems I have listed here to give yourself the extra practice on the basic mechanics. The additional support problems are not AICE problems. They're just the basic mechanic problems, similar to the practice problems I worked throughout this video. If you have any questions, make sure you write them down and bring them to class.